Okay, 7.5, we're going to be analyzing some graphs of quadratic functions. On number 1, it's actually going to give you the graph of this parabola, and then the vertex, which is the point at where this parabola changes directions. It's decreasing all the way until it gets to the vertex, and then it starts increasing. Okay, this one actually tells you what the vertex is on number 1. It is at the point 4, negative 3. So that's simply the answer to the first part of the question. The vertex is. Now, the vertex is a point, which means you do have to type it in as an ordered pair. So you'd have to type in open parentheses 4, negative 3, close parentheses. Now, when it's talking about the axis of symmetry, remember the line of symmetry is going to be the line that cuts this parabola in half and makes each side be a mirror image of the other side. So you need to think of it as an imaginary vertical line that goes through your parabola just like that. So it's that imaginary line right there. So when you're talking about a parabola, this U shape, the line of it is actually going to be, since it's a vertical line, all vertical lines come in the form x equals, because you see right here it says type an equation. Well, the x on every point of this vertical line that cuts through this parabola, the x is always 4, right? At every single point, no matter where you are, the x coordinate is 4 on this. So the axis of symmetry is simply x equals 4. So once you know the vertex, which you do here, the axis of symmetry is simply x equals whatever that x coordinate of the vertex is. Okay? Then when it's talking about what is the minimum or maximum value of the function, the value is always whatever the y coordinate is of the vertex. So the value of this is simply just the negative 3. It's not an equation or anything like that. It's just whatever that y coordinate of the vertex is. And this one happens to be a minimum, right? Because that is at the lowest point of that parabola. Now, let's look at number 2. This time, it doesn't give me the graph. It doesn't tell me what the vertex is. It just gives me the function. Now, here's the way you find, if you're just given the function and you need to find the vertex. Okay, so remember, the vertex is going to be a point with an x and y coordinate. Now, right here, to find the x coordinate of the vertex, you use the opposite of b over 2a. That will give you the x coordinate of your vertex. So again, your numbers are a, b, and c. Just like when you're using the quadratic formula or factoring or anything, your a, b, and c are always in the same spot. So I need the opposite of b. So since my b is negative 16, the opposite of it is positive 16. Then over 2 times a. So in this case, it'll be 2 times, my a is 1. So now I have 16 over 2 times 1 is 2. And then 16 over 2 is 8. Which means the x coordinate of the vertex for this function is 8. Well, once you know the x, then you just plug it in to the function in everywhere you see an x. So you'll have 8 squared minus 16 times 8 plus 63. Okay, and then to save yourself time, just type that exactly how it is in your calculator. So I would need 8, so 8 squared minus 16, open parentheses, 8. Again, I am typing this exactly like it looks here. Plus 63. Hit enter, which gives me negative 1. So all I did was I found, by using the opposite of b over 2a, that gave me the x. I plugged the x into the function, then plugged that into my calculator to get the y, which gave me -1, which is going to give me a lot of information that I need. So I just found that this function, that the vertex occurs at 8, -1. The second set problem says, find an equation for the axis of symmetry. Well, remember, the axis of symmetry is just that vertical line that will cut this parabola in half. So, and it's always x equals simply whatever the x coordinate was of the vertex. The next part says, determine whether the parabola has a maximum or a minimum, and then find its value. Okay, so determine whether it has a maximum or minimum is going to depend on whether this parabola is a regular U-shape or an upside down U-shape. You can actually go to your y equals, clear it out, type in the function, so x squared minus 16x plus 63, whoops, sorry, let me get my window back to normal there. So there's what the parabola looks like. It's not upside down, because if you remember from a couple of sections ago, what made your function reflect across the x-axis, or in other words, turn upside down? If there was a negative in front of that x squared, that's what would have made it turn upside down. So since this is a regular U-shaped parabola, it's going to have a minimum, right? That vertex is at the very bottom of the parabola. So it's going to have a minimum, so it's going to open upward and have a minimum. So the parabola opens upward and has a minimum, and the value, what's the minimum value? Well, it's the y coordinate of this vertex that we found at the beginning. So the minimum value is simply going to be -1. Now, when you go in and have to graph, that's the last part, is it's going to say use the graphing tool on the right to graph the function. Well, when I go in, I'll click to enlarge graph, and then I'm going to pick the U shape out of my toolbox to tell it I'm going to graph a parabola. Now, the very first thing it's going to tell you to graph or plot is the vertex. So it doesn't let you plot any point. You have to plot this 8, -1. So you put the point at 8, -1. So there's the vertex. Now, after that, it'll let you plot any point you want on the graph after you plot the vertex. So you've already got this function in your graph. So if you hit second table, there are all kinds of points that you can choose. So let's go down here to another point that has numbers that are good. So let's see, there's a point at 7, 0, there's a point at 6, 3, there's a point at 5, 8. I can plot, there's my 8, -1 that I already plotted. I can plot any of these points. Let's say I plotted the 7, 0, which would be right here. Once you plot that, it's going to automatically draw the parabola in MyLabs Plus for you. All right, same thing on number 3. The first thing we're going to do is find the vertex. Let's see, our function is 2x squared plus 6x plus 4. So let's write that on our paper. And find the vertex. Remember, you use the opposite of b over 2a. So here's my a, b, and c. Well, if this is b, then the opposite of it will just be -6 over 2 times a, well, my a is 2. So now I have negative 6 over 4. And on my paper, when it says type an ordered pair using integers or fractions, so it doesn't want the decimal. I'm going to teach you a trick in your calculator because this reduces. So in your calculator, I want to see what happens if I have negative 6 over 4 and I hit enter. It's going to give me a decimal. If you come over here and hit this math button, the first thing under math is it says it wants to turn the last answer you had in your calculator into a simplified fraction. So hit enter. So what it's going to do is turn this negative 1.5 into a simplified fraction, which is just negative 6/4 reduced. So again, anytime you want to reduce a fraction, this one wasn't so bad. Some fractions are a lot worse. If you want to reduce a fraction, just type in your fraction, hit enter, and then hit math, enter, enter. That will reduce your fraction. So here is our x-coordinate of the vertex. That's what we just found. So negative 3 over 2 is going to be the x-coordinate of the vertex. So now remember what we need to do is plug in this negative 3 over 2 for these x's. So I'll have 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 plus 4. So I can go and type in this exactly into my calculator. It does all of the difficult work for you. So let's type in exactly what that says. So I'll have 2 open parentheses, negative 3 over 2, close, squared. So again, exactly like it's written on my paper, plus 6, open parentheses, negative 3 over 2, plus 4, and hit enter. It gives me negative 0.5. So again, it doesn't want me to type that in as a decimal. It tells me that in the instructions. So once again, I'll just hit math, enter, enter. And that turns that decimal into the fraction that I need it to be, which is negative 1/2. So let's see. So there is my vertex now. Negative 3/2. And then when I punched this into my calculator, it gave me negative 1/2. So there's my vertex, which is what I need for the first part of this question. The vertex is, and remember, it's a point, so it needs to be written as an ordered pair. Negative 3 over 2, comma, negative 1 over 2. Now, this gives me a lot of information. The axis of symmetry, remember, is just x equals whatever the x coordinate was. So negative 3 over 2. Does this have a maximum or a minimum value? Well, again, since it is not upside down, remember a negative out here is what would flip that upside down. And again, let's go ahead and put this in our y equals to see what it looks like. So 2x squared plus 6x plus 4. So there's where I'm going to graph it. And look, where the vertex is, negative 3/2 and negative 1/2. So just exactly right here. So does it have a minimum or a maximum? Again, it's not upside down, so this vertex is at its minimum. The minimum value, remember, that's just the y coordinate of the vertex. So it's just negative 1/2. And then you'll use the graphing tool to graph it. So again, it's going to want you to plot the vertex first. And when you're graphing this one, it'll actually let you graph. Let me just bring out what it's going to be able to look like. So right here, when you're graphing this one, it's going to give you half marks, right here. So do you see how these go? There's half, there's -1, 1.5, -2. So since it gives you a crazy vertex that has halves instead of whole numbers, it's going to let you plot that. And again, there will be a little cheater. It's either up there, sometimes it's down here. It'll tell you where your mouse is. So just make sure that it's at the point you want it to be. And then you can just go to your table to plot the second point. All right, number 4. Same kind of problem. Let's see, the vertex. So if I have, let's put this on our paper again. My function is -x² minus 8x minus 10. So I use the opposite of b over 2a to get my vertex. Here's my a, b, and c. So here's my b, so the opposite of it will be positive 8, over 2 times a, well my a is -1, so now I have 8 over 2 times -1 gives me -2, and then 8 over -2 is -4. So that gives me, remember that's what gives you the x coordinate of the vertex. After that, I can plug this -4 in to my function, so I'll have negative, then replace the x with -4 squared minus 8 times -4 minus 10. So be careful at this front. This first negative is the negative that's in front. Then I replace the x with a -4. So let's type this right here exactly in our calculator. So we'll have negative, then open parentheses, -4, close, squared, minus 8, open parentheses, -4, close, minus 10. Enter, which gives me 6. So this right here, that gives me the vertex is at -4, 6. Again, that's where you get a lot of information about your parabola. So let's see, the first thing it asks me, the vertex is, well, we just found that to be at -4, 6. So the axis of symmetry is x equals the x coordinate, which is -4. Now, let's think about this one. Does this one have a maximum or a minimum? This negative out in front of that function is what's going to flip that upside down. So let's look at what that looks like in the graph. So let's type this in to see what it looks like. So I'll have negative x squared minus 8x minus 10. So exactly what we knew was going to happen. It was going to be flipped upside down, which means this parabola doesn't have a minimum. It's a maximum at its vertex. And you'll be able to see that its vertex is right where we knew it would be, -4, 6. So 1, 2, 3, 4, -4, and then up 6, right where we knew it would be. So this actually has a a maximum value, since the vertex is at the top. And the maximum value is always just what the y value was there. Now, while we are here, remember how we've been using the opposite of b over 2a, and we've been doing this work to find the vertex. Well, another trick that you can do in your calculator, if you have typed in this function, I can go to hit your second, then hit this calc button. So remember, this one was upside down, so it has a maximum. So let's go and look. Go down here to maximum, and then hit enter. So then it wants to know, is your cursor, your blinking X, which I can see right there, is it on the left side of your parabola. It's not. So let's make it just hit this left arrow until it gets on the left side. Okay, anywhere on the left side. It can be there, it can be there. It doesn't matter. Just as long as it's crossed over the hump. So hit enter. Then it's going to say, okay, put your cursor on the right side of your parabola. So if I just move it back over anywhere on this side and hit enter twice, that doesn't mean anything. Look what it gives me. -4, 6. That's your vertex. You can use that instead of the opposite of B over 2A. Again, that was just second calc. Then put the cursor on the left, hit enter, move the cursor over to the right, hit enter twice, and then it'll tell you what the vertex is. And then it's going to say use the graphing tool to graph the function. Again, the first thing it's going to ask you to plot is the vertex. So you have -4, 6. So you'll have to plot that point first, and then any other point. So remember, you've got the function in your y equals. So if you want another point, just hit second table. There's all the points that you need. Now remember, you're putting this on a graph, so let's find something that'll fit on our graphs. For instance, -2, 2 could be another point. So -2, 2 would be another point, and then once you put that second point, it'll finish drawing the parabola for you. All right, number 5. Determine whether this statement is true or false. So it's saying the function -9x squared minus 4x plus 1 has a maximum value. So let's think about what this parabola is going to look like. What does this negative in front do? Well, it flips it upside down and makes it doesn't matter where it is on the graph, it just wants to know if it has a maximum, which means if it opens like this, its vertex is at the top, which means yes, it does have a maximum. So that would be true. All right, now let's look at number 6. The graph of h of x equals x minus 6 squared can be obtained by translating the graph of h of x equals x squared left 6 units. So let's go back to 7.2, I believe, where we were doing the transformations. Remember what inside numbers did. Inside numbers do move the graph left and right. But what does it do? It goes opposite the sign, right? So this -6 actually moves it to the right 6 units, not left, which means that's false. Now, number 7, the axis of symmetry of this function. Okay, now let's think about this. It's saying that the axis of symmetry is x equals -8. Now let's think of what these outside and inside numbers would do to the graph. Let's see, this is an outside number, which would move it up 8 because you go with the sign. Inside numbers move the graph left and right, so you would go opposite the sign, which means this one would go to the right 7. This negative out front is just going to flip it upside down. So let's see what's going to happen to the vertex. It's going to go to the right 7 and up 8. So right 7, up 8. Here's where the vertex is going to be of that parabola. And it's upside down. So all it wants to know, here's where its axis of symmetry is. So is that axis of symmetry at x equals -8? Well, x equals -8 would be a vertical line right there. So it is not. Its axis of symmetry is actually x equals +8. So that would be false. Again, if you wanted to, you could put all of this right here in your y equals. So -6, open parentheses, x minus 7, close your parentheses, squared, plus 8, and then graph it. So look, it ended up in the same area that mine did. It moved it to the right 7 and up 8. So again, here's its axis of symmetry. That's the line that cuts this parabola in half. It's at x equals positive 8, not over here at x equals negative 8. Now, let's look at this number 8. And let's do this one all in the calculator. It's going to ask me several things, starting with the vertex. So let's look. Let's put this exactly like this in our y equals. So go to y equals x squared minus 4x plus 3 and graph it. Because remember, once I've graphed it, then I can actually find its vertex from this graph. So remember, in order to find the vertex, hit. Now, let's remember, it's going to ask me, it's not going to say find vertex. It's just going to say find a maximum or minimum. And this one has a minimum since the vertex is at the bottom. So if I go to second calc, again, that was just second, and then hit the calc button, go down to minimum. And then remember, it asks me, is the cursor on the left side of the parabola? It is. You can see it blinking right there. So hit enter. Then move it over to the right side. Anywhere on the right side, it doesn't matter as long as you cross through the vertex. And then hit enter twice. So when you get a number like this with 2 point, and then it's got a bunch of zeros, but then a number out here, that's just the same thing as saying 2. So the vertex is going to be at 2, negative 1. So the vertex will be at 2, negative 1. Now, determine whether the parabola has a maximum or minimum value. So if you're looking at it, what's this vertex? It's its minimum. So the parabola opens upward and has a minimum value. And what's the minimum value? The minimum value is always just whatever that y coordinate is. So negative 1. Now, here's something new that we haven't done before. It wants to know the range. And when we're talking about the range, we are going to put a bracket around the number. So what is the y value here? The y value is this negative 1. The range, the parabola never goes below this. So there's never any y values that are below negative 1. It continually goes up from there. To show that in interval notation, I want to say that the y values are from negative 1 to infinity because it goes up forever. So like I was saying, when you're talking about the range, put a bracket around the number to infinity. And no matter what, infinity always has a parentheses. Now, when you're talking about increasing and decreasing, this is when you use parentheses and you're just talking about the x values. So when I'm looking at this, let's see, it's increasing starting at the vertex, because the vertex is what tells you where it decreases to the vertex and then starts increasing. So if it's asking me where it's increasing, here's where it starts to increase. What is the x value at this vertex? So the x value, remember, was 2. So it starts increasing at 2 and then increases forever to infinity. And then the last part says, well, where is it decreasing? Well, it starts decreasing at negative infinity. And then where does it stop decreasing? At the vertex. The vertex, again, that just tells you where you stop decreasing and start increasing. And what is the x value at this vertex? It's that 2. So it's decreasing starting from negative infinity all the way to 2. So from negative infinity to 2. Okay, one more of these, and these are the problems that students have the most trouble with. So I'm going to work through this whole problem again using this other problem. So let's just start off. It's the same questions about this. So let's go to your y equals and clear it out and put in our new function, which will be negative 4x squared minus 4x plus 7. And let's graph it. Okay, so there is my parabola. It wants to know what the vertex is. So does this parabola have a maximum or a minimum? Well, you'll notice that the vertex is at the top, which means it has a maximum. So let's find, by using second calc, its maximum. So is the cursor on the left? It always wants it to start off on the left. I can see it blinking over here on the right, so let's move it just over to the left side. Hit enter. Move it over to the right side. Hit enter twice. So there is my vertex. Now again, some calculators are going to be just a little smidge off. This is the same thing as saying negative 0.5. Okay, and it wants me to not type it as a decimal. It wants me to type it as a fraction. It tells me that in this in the instructions here. So when I type this in, instead of typing 0.5, 0.5 is the same thing as 1/2. So negative 1/2 8. So there's the vertex at negative 1/2 8. Now, determine whether the parabola has a maximum value or a minimum value. Well, this one has a maximum because the vertex is at the top. So let's see, it's got a maximum, and what's the maximum value? Again, that's always the value, whether it be the minimum or the maximum, is always just whatever that y coordinate is. So the maximum value of this one is 8. Now, the range. So let's look at this picture. Here's the range, talking about the y values. So this is going to be different than the last one because this time the y values don't go up past 8, which means where do they start? They start forever, ever down at the very bottom of the number line, which would be negative infinity. And then they don't go past 8, which means they start at negative infinity, and then they go to 8. And remember, the range always puts a bracket around the number and a parentheses around the infinity. Again, so looking at the picture, it wants to know what are the y values. Well, they're everything below this 8, okay? So again, negative infinity to 8. Now, where's the function increasing and decreasing? So now remember, when you're talking about increasing and decreasing, you are talking about x values of this vertex. So it's going up, increasing all the way to this x, which is negative 1/2, and then decreasing after the negative 1/2. So it's increasing from negative infinity to negative 1/2. So once it gets to the negative 1/2, it starts going down. So it starts going down at negative 1/2 all the way to infinity. And the last problem. Okay, so this gives me a word problem talking about a toy rocket that is launched. Now, if you think about a rocket being launched, what's happening? It starts down here at the ground, it goes up, and then at some point it's going to come down. So it's going to actually give you a parabola shape. Okay, so let's go right here and put this in our y equals and look what this parabola shape is going to look like. So let's see, I've got negative 16, we're just going to put x's because we don't have t's. So negative 16 x squared plus 40 x plus 5. And then let's graph it. Now, this one goes off of our graph. If you wanted to see the top of it, you don't have to. I just know I need to know the top of it because I need to know that maximum. I need to know that because what it's going to ask me is what is its maximum? That's going to be the y value. So let's see if I go to second calc and I want to find the maximum. So is it on the left? Yes, there it is. It's on the left side. So let's see, hit enter. Now I need to get it on the right. So just keep hitting the right button. And there it is. It's eventually going to get over to that right side. It passed through the top way up here somewhere. So hit enter twice. So there is your vertex. It's at 1.25, 30. So this vertex is right there. So it's asking me, the rocket reaches its maximum. So what is the maximum? It's always the y value. Oh, whoops. Nope, that's not right. Sorry. Maximum height is going to be reached at 30 feet. And how long did it take to get there? That is going to be the x coordinate of that. It took 1.25 seconds. So let me reiterate again. I was reading them backwards. So the maximum height is the y coordinate, which was the 30. And then how many seconds it took to get there was the x coordinate, which is 1.25.